Good afternoon. Let me see the questions you have. I guess only one student uploaded his question. Wait, I need to get my iPad to draw on the iPad. We do have a class. Yeah, we just I try to answer your questions so you guys can prepare for midterm. So yeah, I would expect you guys put your questions in a Excel sheet so I could look up before. Since now we only have one question, so it should be very fast. Unless you guys have other questions. Okay. So I guess we can get started. How I can share my screen. You guys can see my screen? Wait, oh, I think I should share the question. You guys know which one we're gonna, so the question is, it's page 141, question number 17. So Alex, is Alex here? Wait, let's see. Alex, can you tell me what you are thinking when you do this question so I can know where you got stuck so I can help you?
So the first issue that I had was that it was related to the drawing that was in the book compared to what the actual unit vector notation was describing. So if you look at the picture, it actually shows that P is going at a downward angle. But the unit vector says that P is only -5 newtons of I. So the two are not agreeing, and I'm not sure in that kind of situation which I should trust.
Okay, let me see. Can you guys see my screen? I don't think you can see.
I can see that it says notability.
Yes. Just a second. So anyone else has other questions? So we just focus on this one. And if when we are solving this question and you come up with other questions, you just feel free to ask. Unable, why unable to connect? This is more troubleshooting. Okay, I guess I can use my keyboard. I can use my keyboard to. So let me see if I can use a whiteboard draw. So this is the block. Oh wait, this is not a block. This is, let me see, I read the question. So there's a P X on the block weighing 45 Newton. Everybody is, wait, I share my whole screen. So here's I just took a screenshot. So this is the question 17. So there is a force on the negative x direction, and the block with 45 Newton. The block initially rests on the plane inclined at the angle 15, and the other to the horizontal, which is on the x axis. The positive direction of x is, so basically direction toward this way is x axis. And this one, between the block and the plane, the coefficient of static friction is 0.5, and the kinetic friction is 0.34. In the unit factor notation, what is the friction force of block from the plane? So what I want to know is, so when you do the force analysis, you know, like how to analyze the force, Alex? Do you know how to analyze?
Yes, I was able to make a free body diagram, but the issue was that, again, if you look at the picture shows the P force going in a downward direction, but the unit vector description gives it as going in a straight to the left direction. And so it matters whether it's going down at an angle or whether it's going to the left straight as to how everything is going to be calculated.
Oh, yeah.
So how am I supposed to determine between the two?
Well, if you look at the picture, the plane itself is the x-axis. You see what I'm saying? There's an X at the top of the plane there.
Oh,
so the picture is being rotated like that.
I didn't think about it that way. You're right. I missed that they were saying that that was the x-axis. That's a good catch.
So basically, you divided the weighing the 45 Newton to x-axis, and let's say the one perpendicular to x-axis is y-axis. So you how to say, you basically you can use the total 45 Newton to be x-axis, and the y-axis you digest to two directions, and then you will realize the friction only depends on the y-axis. So because it only depends on the one that perpendicular to the x-axis. So that wouldn't matter how much the force, the P is. It wouldn't matter. So I'm not sure.
It does actually matter to a certain extent, because the part of the problem is determining whether or not the force being pushed onto it is actually overcoming the frictional force. Because if it's not overcoming the frictional force, then it doesn't matter. So the x-axis matters in that respect.
Yes, it only matters in this respect. But when you try to calculate the static friction, like you have to make the one towards the minus x direction, the force equal to the the static friction on the x positive direction. That's all what I'm saying. So basically, if you digest here, there's x-axis and there's y-axis. The y-axis only determines the static or kinetic friction. So you have F equal to mu F. You know what I mean?
Yes.
Okay. And then you can calculate that number, and then you can add it, so the x-axis from the 45 Newton and the P. If this one is smaller than the total static friction, then the total friction, so the static friction will be equal to this, the sum of this direction. If we if the total, let's say, if the P is minus 15, I calculated the Fx is 13.5. So if you have a x direction is 13.5, but you have to add up the P, and which is 28.5 on this minus x direction. So but then you have your static friction is it's 20. It's 22.8. So it's smaller than the total force on the minus x direction. So in that case, you need the block need to move. So so in this in the third question, so you have a friction, that will be the the kinetic friction. Okay, any questions? I think it's hard to understand. Maybe I don't have a drawing here. So this is a block. Let's see. Let me see if I have any questions here. Wait, so Winsor, what do you mean? So this is the mg, right? And this is x-axis. So I can use another color.
No, I was talking about the angle theta, like when you draw it in a free body diagram. If you have the x-axis as that plane there, you know what I mean? Like the bottom half of the, the bottom component, I guess, of that angle would be perpendicular to mg. Do you see what I'm
saying? So when you digest this one, or what how to say when you
For me personally, I think it's easier to draw the free body. If that's the x-axis, I orient it so that it's flat. You know what I mean? Like I would orient it. It's kind of hard to explain without drawing it. But like
you just turn the box so that it looks like it's sitting on the ground.
Exactly. Yes, exactly. And then that angle theta down there at the bottom, if you extend it out, would be perpendicular to mg. I was just explaining it to the person in the chat who had asked how would that angle be taken into account then. And I said it would be below the x-axis.
Okay. Well, I didn't get it. Why you perpendicular to this one, to mg?
Is it possible that is there a way for me to draw on here? I could just draw real quick.
Oh, you can draw. You can draw.
How do I do that?
Yeah, you can. Can you share your screen?
Oh, I don't know. I don't know how to draw on my computer. I was going to say, is it possible for me to draw on that one?
Okay, so what I mean, let me see. I know what you're saying. I think. Where's my whiteboard? So I know you mean like there's a supporting force that perpendicular to the mg.
Well, just here, if you just draw an x and y axis, right? Like, but like away from that free body, like on its own, just like completely separate. If you just draw an x and y axis like a grid.
Okay. Oh, you mean like?
So just draw it on its own, and that'd probably be easier.
You mean you define a different x-y system?
Yeah, and then if you make that, you see how that x now would be, it would be like rotating the incline plane. It would be like rotating it. So then if you extend x out to the left, that angle theta is now going to be below the x-axis. And because you rotated the whole thing, mg is now going to be at an angle going down instead of straight down.
Yeah. I see. You mean this angle?
Like no, the angle theta that's down there in the bottom left corner. Yeah, that one.
Yeah, this two will be the same.
Yes, exactly. Sorry, it's so hard to be able to explain it. I was just trying to explain to Hassan in the chat how that angle theta would then be represented, because then if you extend the x-axis out to the left, then that angle will be below the x-axis on the left-hand side. That's all I was saying.
Yeah, thank you. So any other questions, or you still have any question for this one? I believe you guys have a Discord like group. Like if I have any questions, you can ask in the group, or you can ask me. So I feel like your classmates can help a lot. I don't think so. I don't think the lab due date is extended. Wait, Ellie, what do you mean? Ali, my God, what's there? So we don't have the due date is not extended, but if you are late for 1 or 2 days, it should be okay. I know someone wrote me an email for, okay, then you can finish your exam. So, but yeah, you have to submit before, wait, today, Tuesday, before Friday, I guess.
Speaking of the lab, could I ask a question about the lab?
Yeah, of course.
Okay, so I have a write-up for the lab, but when I was making the slope for the velocity versus average time, I got a slope value, and I don't really know, like, I'm not exactly sure how to ask this question, but the best way that I can ask it is I don't know what that slope means, because I know that it's supposed to be talking about, I mean, essentially what you're taking is you're taking an averaging of some y values over some averaging of some x values. So it should be kind of an average acceleration when you're doing that velocity on the y, time on the x. But for individual values that I was getting within that area, they weren't exactly lining up with that. And so I'm not entirely sure what that slope number is actually supposed to mean.
Can you tell me which slope you're working on?
The slope that I'm talking about right now is in part 1, when you're supposed to, it's for question 12 of part 1.
Okay. So you're not very sure what slope means?
Well, I know what I mean, like I can calculate the slope. I have the number for what the slope is of this line.
Okay.
But I don't really know what that means. Like I don't know, like, other than I know that because there's a negative number, there's an inverse relationship. So as time gets greater, velocity gets slower, or as time gets smaller, velocity gets faster. That much I understand, but the number itself for that slope that I calculated, I don't know what that number actually means.
Okay. Did you include the original points, like 0, 0? Like when you draw a slope, you at least have if you want to have a line or anything, you at least have 2 points, right? One is the one you calculated. Let's say you have a velocity average. Let's say just make up those numbers. Velocity average is 3, and your time average is 1. So you have a slope, not slope. You have a point at 1, 3, right? But this is just 1 point. Did you include original point from 0, 0? Then you can have a line. You know what I'm saying? Oh, I'm muted? Oh no. Oh my God.
Sorry, I was muted. Excuse me. I was trying to answer. I'm sorry. So what I didn't have it connecting to the origin. I had it as a series of all of the various points that were all velocity averages and time averages. And then I created a line through all of those because they make a pretty steady line.
Okay. But yeah, okay, so here they made the, so you have a 3 average velocity and a 3 average time. Then you have,
I have 6 average velocities and 6 average times, which gives me 6 points. And so those 6 points create a line pretty consistently.
That doesn't mean anything. I tell you, that doesn't mean anything.
That makes me feel so much better because I could not understand what it meant. And now I know that it doesn't mean anything.
Yeah, it doesn't mean anything because this is, you're supposed to plot, there are 6 different numbers. You're supposed to plot one of them and include the original point.
Oh, so it doesn't matter which one I choose. It's just choosing one, and the graph is just a 1.
Yes.
Okay. Now I understand, and that makes a lot more sense. And the same thing I'm assuming then for 13 as well is just from the origin to one of those points showing that ratio.
Yeah, I recommend
Got
you just take one, the first one. Otherwise, if you take the first one, yeah, you take the number 12, you plot 1, and then you keep working on your number 13.
Got it. Okay. That clears up so much, because I was just like trying to figure out what that number meant so long, and I just couldn't get anywhere. And now I realize that I was just totally off. I feel better. Thank you.
Okay.
Miss Wei,
Yeah.
wait, it's to do 6 different planets, right? Like, so you have to put 6 different names for the planets, or yeah.
Yes.
You have to do it 6 times then. Oof.
I mean, you don't have to plot 6 graphs though. You just plot 1.
But like, there's like 6 planets, assume. So you have to put the name, mass, radius, density, and like find all the velocity and the time for each of the 6.
Yes.
Oh, okay.
Yeah, if you have like I think the last time I explained in the video, you can check the video if you have any question, or you just write email to me. Sorry, Arthur, I haven't replied to you, but I'll reply today. I just got my computer. Yeah, and anything else?
I do want to give other people a chance, but I since Monday, I was doing some more problems, and I do have another question for another problem later on, but it can wait if other people have other questions.
Yeah, okay. Other question has a problem or has a question?
I think that's about it.
Okay, Alex, you can ask now. If someone else has a question, they will ask after you.
Okay, great. Then going on to page 143, question number 33.
Oh, my computer takes a long time to go there.
That's okay.
Oh, sorry. So question, which one?
33
30.
on page 143. It's the top one.
Okay. Let's see. If you have any question for your homework or your, like, let's say you have your midterm finished, you can also, you have any question don't understand, you can always feel free to ask me. 143. It's close. Okay, question 30, which?
33.
33, okay. A 1,000-kilometer boat is traveling 90 kilometers per hour when its engine is shut off. The magnet, oh, everyone can, I need to share my screen. Okay, this one, make it bigger. So the magnitude of the friction force F between boats and water is proportional to the speed of the boat. So basically this V, this is not unit, this is like the speed of the boat, where V is in meters per second and Fk is in Newton. Find the time required for the boat to slow to 45 kilometers per hour. So you can say, so okay, you tell me what's your thought when you read this? What your first, what's your questions? Or when you work on this question, what do you think?
Well, so what I had was trying to do some kind of figuring out of what forces are being acted on, and basically it's the force of friction. But the issue for me is that with the force of friction being a variable, because velocity is changing constantly, so
Yes.
the force of friction is changing constantly. I don't know how to incorporate that using the familiar sort of equations that I had been seeing up to this point.
Okay, let me see. So basically, you can list what you know. So here you have a boat. The initial velocity is 90 kilometer per hour. Okay, we want to make the unit unified. So here we see the V is meters per second. So we have to make this 90 kilometer per hour. I think it divided by 3 point, what's the number? Divided by 3.6.
Yeah, 3.6 is 3,600 seconds in an hour.
Okay, 3,600 per hour.
Yeah, and then it's 1,000 meters in a kilometer, so it becomes 3.6.
Okay. So then, so we know the friction. We know the friction F K equal to 70 V. So here we know the only the only force on the boat was the friction, right?
Yes.
I mean, it also has weight. It's and the supporting, but I mean the only force that stops the boat is the friction. There's no pulling force. There's no other force. Even it has supporting force and its weight, its own weight. But we don't consider this too because this is all perpendicular to the water. So we only focus on the force that make an effect to the boat to slow down. So we know F equal to 70 V and F equal to MA, right? So this is the only force A. So you make these two together, then you can figure out what's the A value. The A is acceleration speed. So the A definitely will include V. And you want to know, it doesn't matter, you just try to solve like a, you just try to solve V. So what time it takes you, okay, are you following me? Sorry, I feel like I need
so far, I understand that the 7dV is equal to MA.
Yeah.
That much I am getting, but we then still have a constantly changing V and an unknown A at this point, which will also be changing.
Okay, yes. So what I want to say here, the acceleration speed A, it equals to 70 V divided by 1,000 kilometer, right?
Yes.
Not kilometer, kilograms.
Kilograms.
Sorry. Then you have it's 0.007 V, right? And then we want to work out when so you just have one equation. So VT equal to V0 plus AT, right? You just use this equation to solve. So VT is 90 okay, this is not 90. It's 3,600.
90 divided by 3.6.
Yeah, 90 divided by 3.6 is VT equal to V0. V0 is 45 divided 3.6 and plus 80. 80, you don't know, wait, 80. 80, you have 80, you have 0.07 V times T. This V is changing to, so you don't care, I think, wait a minute, it's not a constant. Can we take a VT? So if they ask you when it becomes, when the boat slow down to 45 kilometer per hour, I think the final, then I know the A is changing, like it's started from 90 kilometer to 45 kilometer times 70. But you have the final velocity that should be 45 kilometer. Or other students have any different opinion?
I'm pretty sure we'd have to integrate to completely solve this. I doubt he'd give anything this complicated on the test. I think this would take quite a while to solve, because I think once you're given everything, because it's variable, you'd probably have to integrate that whole thing.
Right. Yeah, that was the part where I wasn't sure about the integrating. You're probably right that this won't show up on the exam. I was just like wanting to,
so we
just in case.
We used calculus to derive these equations, but like, I mean, at least so far, we haven't done any examples where we needed to integrate to solve anything, because that would take a hot minute. There's no way that he'd expect us to do multiple of those in 40 minutes. But you never know. You never know with this guy.
Yeah, I feel like a little bit lost here. So I will try to work on this question. And if I get an answer, hopefully you don't have this question in your exam.
Yeah, no, I apologize that I didn't give this to you before. I literally didn't work on it until after I'd already submitted everything. And that's why I was like, only if there was time. I've been working through the other stuff, and I've been feeling a little bit more confident about the other stuff earlier on in the chapter 6 problems for 6.1. But
okay, yeah, just work on this one, and I'll give you an answer. Hopefully, if I got this answer, you have an answer for this one?
Oh yeah, the answer's in the back of the book. The answer is less what I'm interested in than the process, because I have only been doing odd problems specifically so that I know that I can like check the answer and make sure that like, oh, that is actually what it's supposed to be.
Oh, doesn't have any calculation process, just give you a number? That's the answer?
Yeah, well, in the back of the book, it just gives you an answer of a number. So it doesn't really tell you how you get there.
Yeah, that's not good.
Yeah, so that's why it's like, if I get the actual correct number, I'm like, okay, I think I know what I'm doing. But it's always like hard for me, because I don't really get to see the process if I don't really understand what's going on.
Okay. Yeah, I'll need some time to work on that. Sorry.
No worries.
Yeah, okay. Well, I don't know. But I think the midterm wouldn't be so hard. You can definitely work on the equations that are commonly used, and yeah, try to prepare for that.
That makes me feel a little bit better.
Any other questions? So you have an exam tomorrow?
Yes.
Yeah, so regarding the lab report due date, you can submit the latest the Friday, so I can grade them on the weekend. Yeah. Any other questions?
So we can submit by Friday and we won't get points off?
You better submit it as soon as possible. Yeah, you can submit it by Friday. No
okay,
points
thank you.
at all. Yeah. All right. If there's no more questions, then I guess you can study for your exam. Then if you have any questions, you can always drop a question in the Discord. Like and also you can ask me. Yeah.
I mean, if like, given the fact that we have some extra time, I don't know if you would be comfortable with this at all, given the fact that obviously, like, but I wouldn't mind doing then maybe one of the 2 dot even questions that's in the book right now, having us just work through one together as a group here, just to sort of see if we're all on the same process about this, and then that way, like, it, given that it's an even question, it's not going to be something I would necessarily find in the back of the book for the answers. So I know that if I get the same thing as you, then I'm on the right track.
Okay, you mean like we work on 40?
Well, and what I would say would be something that would be in the first module 6.1, because he said that we weren't going to be doing anything from 6.2 or 6.3.
Okay.
So I mean, I would say anything from anything from 16 to 32, any one of them that's an even number,
Okay,
would be really helpful for me.
So can you tell me what the dots means? Like, it means the difficulty.
Do you see those 2 dots to the left of each one of those numbers? It's difficulty.
Okay.
So 1 dot is easy, 2 dots is medium, 3 dots, which was that one with the variable friction, was 3 dots. So 2 dots seems more likely as something we would see on the test.
Okay. Which one you want to work on? You can just random.
Randomly choosing one. Let's do 30 because we're right there by it.
30?
Why not?
Okay. So here, so a toy chest and its content having a combined weight of 180. Okay, so this is 180. Coefficient of static friction between the toy chest and the floor is 0.4. So when I do, if you're okay, so when I read the question, I normally just put all the informations on here, but I cannot draw here. I just I have my side a pen and a pencil here, my paper and the pencil here. So I just draw, put all the information on the image. So I put on the information. I don't have to look back to read the question. You see what I mean? Like this
Yes.
is, I will draw a box and then the weight is 180. And then the mu is static mu1 equal to 0.42. The child is here, is attempting to move the chest across the floor by pulling on and attach the rope. If this angle, so you can also make a rope here and with the angle theta, because the theta is 42. What is the magnitude of force F that the child must exert on the rope to pull the chest on the verge of moving? So basically you have to overcome the, okay. So you have, if the box is moving, you have to overcome the static friction to make the box moving. So you can say, so basically, can I draw? I don't think I can draw here, but I can. Let's see. Okay. So we have a box here. And this is the weight 180. And then definitely you have, sorry, this is not. So this is the floor, and you have also a force, a pulling force that is pulling, and this is 42. And the mu equal to 0.42. So basically you say, so this is all the information that a question gave you for the first question. We can like work on that. This is the weight. The weight, that means, so the floor always gives the box supporting force. The same, they have the same magnitude, but a different direction. So this F equal to 182, right? And then if you want to calculate F, the static friction is equal to mu F. We can, it's mu F. So we see this is G.
I think there's also a, what's it called? A vertical component to the force there. That would be in that equation too.
That's what she's saying. The vertical. Oh, you're talking about the what the
yeah,
pulling?
yeah, it would be like F, what's it called? F sine theta or something.
Yeah. This is F1.
That's I see what you're doing. Sorry about that.
This is, it's okay. Let's see another pulling force. It's a P, right? Then you have F. This P can divide it by to the X axis and the Y axis. We say P. So we just want to focus, like we try to see the F. This is the friction. We get this one. This is the supporting force, and also we have we have another pulling force we have to analyze. So here F, the P, we see here. Px, we call it Px. Here is Py. So you see, we have all this, then we can, we have to, okay. So here we have to write all the equations that makes, so we say Px have to be big enough to overcome the static friction, right? At least. And then, so we see the total, I mean, so we know now we're analyzing, when we try to analyze the forces, we analyze one direction, and then we change, let's say we analyze on the horizontal direction, and then we will focus on the vertical direction. So in this way, we wouldn't miss any force. If we're analyzing the supporting force or the pulling force, sometimes we get maybe maybe we'll miss one or two. So we analyze all the forces in one direction, then that could guarantee we wouldn't miss any force. Now I change a different color for, this is for the horizontal X direction, right? Okay, so here we have F. So this is all the forces. And in the Y direction, we know G is pointing downside. And then we have F1. F1 plus P, Y. So this is all the equation you get. Do you miss anything? And
I do have a question. It's going to be F1 plus PY. Yeah, because the normal force, got it. Okay, yeah, I'm following. Sorry.
Okay. So, and here we also didn't write out how we calculate Px and Py. I'm sure you already know. Like Px is P cosine 42. Py is P sine cosine 2, sine 42. Right, Px, Py. Here there's no direct number for Px, Py. You have to calculate from P and the 42 degree, right?
Yes.
You know, okay. So these two, you have to calculate px and py, and then you write all this out. Then you know. Now it becomes easier. So we can calculate px. There will be a number. Wait, there will not be a number. They are asking you how much they need to get a p to make it the box is moving. But here what we can get is, let's see. You can write, if you don't know anything yet, you just write something you don't know. Then in the end, you can come across everything, then you can solve it. Okay, let me calculate here. So I don't write it on the blackboard. It's hard to write.
So my question is, when figuring out the y aspect of the force for friction, because what this is really asking is what force is the max frictional force, static frictional force, because anything more than that, the box is going to move. Then that's going to be mu times the normal force, and the normal force is going to be that the weight plus the py sine 42, correct?
No, that'll be just F.
Just F.
Yes.
So the normal force does not include what is being
No, you know why? Because why we have when the friction was generated, it's because you have a supporting. Let's say you have a contact, and you have a then if you move, then you have a friction, and you know here py is not a how to say, it's not the okay, py is not something that generated okay, so it's not has nothing, the py has nothing to do with any friction between the box and the floor.
But shouldn't it though, because it's lifting the box slightly off the ground so that there will be less friction?
Yes, the less friction. You know why it's less friction?
Because
You could let's say before you don't have a p. Let's say f equal to 100. No, it will be 180, right?
Right.
And then you're right. When you pull in this direction, you start lifting the box, so the friction will become smaller. So F always equal to mu F. That means F is smaller. Why F is smaller? Because it has the extra force to lifting. So the F is become smaller because F plus Py always equal to G. You
right.
know what
And
I mean?
so what I'm saying is though that if that force that we're talking about, the mu F for the force of friction, is getting smaller, that F is getting smaller, then that means that we're subtracting the pulling in the py from
so
F. So it's mu times, oh, sorry.
Okay, go ahead.
So it's mu times the quantity F minus py sine 42.
Yes, so the F, you tell me the F, which supposed to be G at the beginning, right?
Right, but because we're adding and a pulling, we have to include that as well. So it's py sine 42. But we're subtracting that from the initial F because it's coming off of the ground.
Yes, that's correct. Then
okay.
The F, you just don't want to confuse other people. The F you're subtracting from is G actually, right?
Yes.
Yeah. Just make sure we are on the same page. So yeah. Yeah, so you have F here equal to J minus Py, right? Because you can use this equation.
Yes.
So then you can calculate. Okay, let me go quick. 180 minus P cosine. Wait, it's sin 42, and times mu, which is 0.42, equal to P times cosine 42. So you can solve P, right? I mean, like basically you have this equation, and you know px and f. You can use mu times f, which is mu times g minus py.
Right.
And then you figure out there only one unknown in this equation. That would be p. So you can solve p.
And so, but then we have to do some sort of like backward, because we can't do like, so it's p cosine of 42 is this number that we have. So then we have to divide by cosine of 42, and that gives us p, right?
So can you write down, so when you have all this information, can you write down the equation for px equal to p equal to f?
Yes.
Okay, tell me what you read about. If you don't know p, then just use p. I'm
Right.
sure cosine 42 we have a number.
So what we've got is that px. I'm sorry. What
Okay,
what am I supposed to actually be? What equation am I supposed to be putting out here?
You just tell me what's so from this equation, what you get, how you could get all the information you know from all this, and to
Right.
extrapolate.
So the px is going to be equal to the force of friction, and we know what the force of friction is, and we know that px is p cosine of 42.
Equal to?
P cosine of 42 is equal to this force of friction, which is the mu f. And so then we divide both sides by cosine of 42, so that gives us p by itself.
Okay, it's okay. It's not, we don't have to hurry to solve p, because now you have so many unknowns, right?
I thought the only thing we don't really, because we know what the force of friction is, because we know what mu is and we know what f is.
Yeah, f is, you cannot solve f either. Can you solve f?
Yeah, because f is g minus py.
But what is py?
Py is, oh, yeah, you're right.
So if you write everything together, then you see p equal to f cosine 42 equal to mu f. The mu f equal to g minus py. So py you also have use p sine 42 to represent. So now you solve all the unknown you use p to represent all the unknown numbers. You see what I mean? So you just write down. Can you write down like a px equal to f, and what represents px, what represents f?
Yes, I'm doing that right now.
Okay, then you tell me what you get.
So px is equal to p cosine of 42.
Yeah.
And f is equal to mu, which we know is 0.42, times f, and that quantity is 180 minus p sine of 42.
Right.
And so at that point, then do we want to actually move the mu times p sine of 42 over, so then that way we have p cosine plus p sine, and then we can actually separate those, and then we would.
Yeah, that's how you solve p, right?
Right, and so then it's p
I'm
times.
sure in the exam they will give you a sine 42, cosine 42, the number, so you don't have to. I mean, you can always use this number to represent the sine 42, or is sine 45 or 42?
It's 42.
Okay. Yeah. So there will be only one unknown, which is p.
Okay.
Right?
And then from there we get p is equal to 0.42 times 180 all over cosine of 42 plus 0.42 times sine of 42. And that'll give us what P is, what P needs to be. Okay, I'm following that.
Okay. Is it so? Any other students have question for how we get P? How we okay, P
So
actually.
what was the final equation that you ended up with again? I just want to make sure it matches up to what I had.
So it's P cosine 42, which is Px, equal to mu, then bracket G minus P sine 42.
Oh, you're saying B minus mu bracket mg minus p sine 42, right? And then you distribute the mu, you bring that to one side, factor out the p, and then divide both sides by cosine 42 plus mu sine 42. And that's, yeah, okay, cool. That's exactly what I got. Awesome.
Okay, that'll be the equation here.
Yep, that's no, yeah, I just want to make sure it was exact that we got the same thing. Want to make sure I didn't do anything wrong.
It's on the verge of
okay, and any other questions?
That's part A. Part B is write an expression for the magnitude F required to put the chest on the verge of moving as a function of the angle theta.
So you already have this.
Right. That's kind of what I thought was. That's exactly what that is already.
Okay. So then let's double check. So then where to put the chest on. So okay, you don't have to solve anything.
Right. It's just writing it at where theta is a function as opposed to just an angle. And then
Okay, then we can say determine say the value of theta for which F is the minimum and the minimum magnitude. So we can make sure F can be minimum. We use minimum. So we have to understand what minimum mean here. Minimum means you have you determine, because you say if let's say if it's 42 degree or it's 90 degree, then they will definitely 90 degree is not if the angle changes, then the px and py and px will change.
Yes.
I think if you were to find the minimum, I think you're going to end up having to take the derivative of that equation.
Yeah, that absolutely is what you're going to need to do, because that when you find out where that f is going to be hitting zero, or that the derivative of f is going to be hitting zero, is when
exactly.
Yes, that is exactly the case. And I agree that at that point it's again something that's
probably I hope that's not on there.
But
I have a feeling I could see part A being on there, but I'd be surprised if you put anything more than that with the
No, I feel like, I mean, not that I wouldn't mind you trying to explain some of the other stuff, but it's definitely not something that would be directly related to what we need to know for tomorrow.
Of course. No.
So why you guys have so many derivatives on the question?
It's not us who wrote these questions. Ask the book.
Yeah, like I have a feeling he wouldn't be asking anything of this if he's given us 40 minutes to do stuff. If you were to do, I feel like this, if you did parts A, B, and C all the way through, that'll take 20 minutes on its own.
And also, like, I mean, obviously some of it, like half of this exam as it is supposed to be doing stuff that's, you know, dealing only with frictionless surfaces. So we're not even dealing with all of the same kind of thing here. So this is the hard end of what we're going to be facing on the exam. So it definitely isn't going to get that much harder.
Okay. But can we solve this F minimum?
So if we were going to do it, would we potentially, so we have our equation of P, and then we have our mu, which is going to be a constant, and we have our 180, which is going to be a constant, and we have our cosine of theta plus mu times cosine of sine of theta. And then what we want to do is we want to take the derivative of that and find out when that is 0.
So minimum, it doesn't mean 0. I think it's not, you don't have to use the derivatives.
Okay.
Just my hypothesis. I think so far I didn't say there's any thing, because you have this equation already, and now you get P equal to, let me see, P equal to, okay, we have to use, okay, I think here we have a cosine 42 plus mu sine 42 equal to mu g, right?
Yes.
And then you want to get P equal to mu g will be 180 10.42.
Yes.
75.6. 75.6 over. So you have to solve this one. How could you cosine
of 42 plus.
Now it's not a cosine 42. Now we say cosine, if we want to solve minimum f, which is p here, right? We have to find the minimum. No, we have to find the maximum of this. So we have to find the maximum cosine 42 plus mu sin 42. We make it bigger enough so we can get a small.
So then p gets smaller. Yeah. Okay.
So how can find.
So when it's cosine of theta plus mu sine of theta at its smallest value.
Smallest.
Or biggest value. Biggest value.
Biggest.
Yes.
Yeah, biggest. Can we do something? Yeah, I think that's the key, how to make it, because now we are changing, if we change cosine x, then sin x will be changing. So we have to make it to be in one.
But that's why it seemed to make the most sense at this point to do a derivative, because if you have cosine of theta, and then you just take the derivative of cosine of theta, then and you do the sine of theta, and you get the derivative of that sine of theta, then you have these two things, and then you find out when cosine of theta plus, or the derivative of cosine of theta plus the derivative of sine of theta is equal to 0. That's going to tell you where it's a min or a max.
Oh,
and
yeah.
So then you would just check that and say, oh, okay, this is actually when those numbers are biggest, and this is when they're smallest, which, given that they're both periodic, you'll probably get both a min and a max. And so then you'd be able to determine from there just by plugging in.
Yeah, I try to think.
At least that's how I would go about doing it. If you have a better way, I'm open here to hear it.
So you do the derivative, let's say the cosine x equal to sine x. I mean, it's derivative, right? Is that what you do?
I'm saying you take the derivative of cosine of x plus 0.42 sine of x. Okay. That whole equation, you take the derivative of that, and then that's going to give you a negative sine of x dx.
X. Wait.
Plus 0.42 cosine of x.
It's minus, right?
No, it's for the derivative, once you derive sine, the derivative of sine is cosine, and the derivative of cosine is negative sine. So that cosine of x becomes negative sine of x, and that 0.42 sine of x becomes just plus 0.42 cosine of x. And this is all times dx. But
a little bit confused here.
we're talking about taking the derivative of cosine of x plus 0.42 sine of x.
Yes.
That one. Yeah, that part of the equation is that derivative becomes negative sine of x plus mu cosine of x.
Oh, yeah. So
and then that's when that equals 0. So it's basically when 0.42 cosine of x is equal to sine of x.
Okay.
And so, that's going to be a maximum in there.
Yeah, cosine x. We still have to figure out. I just don't know how to calculate. Then after, how do you calculate x?
Well, that's a very good question. I don't think that I have an answer to that immediately. It would take me a second to figure out because, I mean, obviously what you would want to do is figure out some point at which sine of x is going to be significantly enough bigger than cosine of x that it's 0.42 times as big, or I guess smaller than cosine of x, so that it's 0.42 times as big. But
I wonder if there's any, you remember, like there are some equations that make a cosine convert to sine, or sine convert to cosine.
Oh yeah, you could do that with the half angle formula. But that would actually be, or actually you need sine squared or cosine squared. You could square both, and then from there you could switch your cosine squared into 1 minus sine squared. That actually, it seems like it would work. So if you squared everything, so
let's say here's the theta. How to use the theta? 0. Okay, let's say this theta equal to no. This is x equal to 2 theta. 2 theta. Let's just 2 theta. Then we can have a 0.42 cosine 2 theta. 2 theta, how 2 theta minus sine 2 theta equal to 0. Can we do this? Then we can convert to like a theta. Then we can try to solve theta. And then solve theta, then we can solve x. I just my thought. I don't know if it works.
I mean, that's absolutely one way to go. The way that I was looking at it was if you just squared everything. So you get mu squared times cosine squared is equal to sine squared. And then you turn cosine squared into 1 minus sine squared.
Yeah.
That seems like it would be an easier way. Not that what you're talking about would also work. Absolutely.
Yeah, that's
but
squared,
this,
right?
So it's mu, that squared.
Squared, then
minus. I moved the sine x to the other side because I know that they equal each other. So that would be equal to sine squared.
Oh, that would be more easier, I guess, maybe.
Sine, yeah, so mu squared
x
minus
square.
Mu squared sine squared of x is equal to sine.
And then we can get, we can definitely use the cosine x squared. Oh my God, I forgot those equations. I need to.
Yeah, cosine squared of x is equal to 1 minus sine squared of x. I'm in calculus right now, so I'm getting a lot more practice with it.
Okay, good. So then we can take a mu square out. So be cosine Okay, it's cosine 2x. 2x minus sine.
So cosine of x squared. Cosine of x squared plus sine of x squared is equal to 1. So if we want to get cosine of x squared into sine of x squared, we just say that cosine of x squared is 1 minus sine of x squared.
Right.
So that turns into 1 minus sine squared x.
Okay, so now we have a sine squared x on the other side.
Yeah,
right?
we have a sine squared is equal to sine squared.
Okay. Yeah. Oh, that's interesting.
Yeah. This is definitely, by the way, for sure, I know now is not going to be on the exam, but this is something that I can do.
Okay, so now we have only sine x squared. We can solve that.
Right. So then what you do is you just distribute out the mu squared and then move this mu squared sine of x squared over to the other side, pull out the sine squared x, and then that gives you mu squared over this mu squared plus 1 is equal to sine of x squared. And then you take the square root of that, and then you get mu over, I'm going too fast, I know.
Okay. Wow, thank you. I also learned. Yeah, that's an interesting question. And you determine that magnitude.
Yeah, and so the ultimate answer for finding out when it's going to be at its max is at arc sine of mu over the square root of mu squared plus 1.
Mm.
That would be our value of theta or x or whatever we want to call it, such that you would be putting in the least amount of work to pull it.
Yeah. So once you convert to only one unknown, then you can easily solve that. Just like how we get from here to here.
Yep. It's all just like figuring out the right equation to plug into so that everything else disappears except for one variable.
Mm. Okay, I think you're ready for the exam.
I hope so. If I'm not, man. Anyway. Well, I'm done with my questions. I don't know if anybody else has anything else at this point.
Okay, anyone else? I think I really like it. We can work together to really solve some problem. Like, I really like this process.
No, Professor, but the only question I do have is that on these recitation weeks, I know you want us to submit questions and whatnot, but sometimes I don't have a particular question, but I think doing this every other week on the non-lab weeks, just meeting and going over, textbook problems and stuff people might not understand, I think it'd be really beneficial to do it regardless.
Yeah. I 100% agree on that. And I think what would be really helpful for us is if you actually picked out some even questions from the book, just that you worked out beforehand, even two or three or something like that, because I'm not likely to do the even questions because the answers aren't in the back of the book. So I won't know if I did them right. The odd questions I will do.
Work on that. I think also I think it's very enjoyable to work together. Or if you have a question beforehand, then you can send me, then I can work before. So we can, yeah, definitely. I think I really like it. Yeah, we can definitely, next time we will, maybe after next time is our live session. I mean, next week, then we will keep going with the recitation part. Yeah.
That'll be great.
Yeah, that would be fantastic.
Okay, I hope you guys can ace your midterm.
Me too.
Yeah, me too.
Me too.
Oh, Camel, you're here. I'm surprised. Hi, Camel.
I'm always here.
Oh,
I hope he gives us. Can he give us more time for this midterm? The 40 minutes I feel is really cruel.
I mean, it's not me. I don't I'm not responsible for your midterm.
Could you ask him to add 5 more minutes?
I mean, I'm not sure I can because it's for everybody. It's not just for you. Definitely, if 45 minutes, they wouldn't ask you for 2 hours question. You definitely can finish with 45 minutes.
Oh, also, I feel like with Blackboard Collaborate Ultra, sometimes like if you don't press that save answer button, I noticed my answers won't go through because for my Calc 2 class, when I was taking this quiz, I forgot to hit the save button and it didn't score the problems I didn't press the save button. Sometimes it does it automatically for you. It will check that save box. But like if you don't check the save box, I notice my answer won't submit and I won't get points for the credit. So
yeah, you just make sure to press the save. I'm not sure how the.
But sometimes it does it automatically. I noticed before when I click for next answer, and sometimes it doesn't.
Yeah, I've been experiencing it automatically. I haven't had that problem that I'm aware of yet.
Yeah, I always forget to check the box sometimes. But sometimes it does it for me, so that's why I don't really remember to check it, because sometimes it does it for me.
Yay, online testing.
Okay, what time is now? It's okay, then I think we are able to finish all this question. Yeah, 9. I think that'll be okay. Sorry, I have I have another appointment, so that was late. Yeah, I think that'll be all.
Oh, just to make sure, you said you extended the lab report till Friday?
Yeah.
Okay,
So
thank you.
I wouldn't change in the Blackboard. Maybe Blackboard still says you are late, but it's okay. I wouldn't deduct any point from you if you submit it before Friday. Yeah. I mean, not before Friday, before Saturday. All right, then I hope you can prepare for exam, then bring me good news next week. Thank you.
Thank you.
Bye.
Thank you, Professor. Take care.
Bye.